Now, back another one where we are going to be learning about the standard libraries and string handling or character arrays handling in C programming language. Before getting into it in the future lectures to the most advanced topics of this programming language. But before we do all that, I just want to give a quick note.
Abi şimdi biliyorum ama çok rüzgarlı gibi geliyor yani sen konuştukça böyle üflüyormuşsun yani bir şeye gibi geliyor ses. Bir de
Şu an nasıl?
şu an daha iyi.
Okay. I just want to give you a quick note about a keyword we use in C programming, although some may say it is obsolete. It's still widely used in especially some error handling contexts, and that is the go-to statement, which is basically a conditional statement again, not directly but indirectly, because control flow is the thing, is the concept, is the term associated with if-else keywords. The control flow is the umbrella term for what their functions are in a programming language. So this is another way to do control flow, just in a more indirect but sometimes more useful way. I'm not gonna write some code in it with it because it's not about the main course of this lectures, and also it's a pretty small thing, so we're just gonna show it here. You label some place of your code with some name, and you put the colon at the end of it, and you tab and put your code below the line. And then once you use some go-to statements and the name of the label you've given it somewhere else in the code will automatically jump here and execute that. And this is usually used in, a context inside of a function, because the go to statement is it is terminated once the function is terminated. Like, for example, if I had another function continuing below this bracelet, not bracket, bracelet, it would not be included in the jump here label, and it would be only bordered with this context of this function. So that's a pretty cool concept, I think. I like to use code, and I've got some notes here before coming to the class today. I put some notes about what I gonna lecture you, because this one is a little bit more complex than the previous ones, and I just have to do some research to be able to tell about this to you. And let me how to do that. So better. Now, before starting with string literals, which are arrays of characters, really, we are going to see a little bit about arrays, because we need at least a description of what an array is in order to understand what a string is. But we're not going to go into deep with the arrays. We're going to do that in the next lectures with pointers and structs. And as I've said in the group WhatsApp chat, the pointers, the arrays, and the structures, maybe you may include the union and the enums here, are pretty cool and deep and low level concepts, at least when compared to the now pretty emptied world of computing. And we need to learn them in detail in order to understand how a computer works. And it's a pretty cool concept, I think. An array is an array, as its name suggests, it is a set of elements. You may think, but, so it is not a set of elements, by the way. Mathematically, a set is a structure that holds some array of numbers, so to speak, that are all distinct. So each element can be can exist only once in a mathematical set. There's a specific order to how they are grouped. In Turkish, we call it a küme. But an array is different from a set in the sense that the elements may be reused like so, and the order matters. Now, the first element of this array, as we specify with the following syntax, is 1. You can say that for each of the elements, each of the members of the array, and it will be true because the order matters and it does not change every time you use the array. It is an ordered list of elements, basically. It is a data type that can hold different data types, which includes an array as well. An array will be composed of many arrays, and unlike Python and any other programming language you might be familiar with, C does not support the different type arrays. So each element in the array must be of the type that you specify before writing the name of the array, which in this case is integer, and you have to put these brackets after the name of the array you define to notify the program of the fact that you're defining an array here. And if you really want to do that, you can also specify the number of elements the array has, but you don't need to do that. The compiler will do that for you. Will allocate the required space in the memory for you by counting how many elements you put up here. And lastly, for the indexing, we index the arrays 0, like this is the 0th element. This is the first, this is the second, this is the third and fourth and fifth. And you may be a little bit flattered with this if you're just beginning to program, but in the computing world generally, this is the standard that that any list starts with the 0th element, not the first, and this usage is correct. And one last thing to show before going on with the string literals, because as I said, we go way deeper into arrays in later lectures. So if you think we're missing some things fundamental here, which we do about arrays, we're missing them consciously. Forgot the word. Yeah. This is also possible assignment to a value of an array, to an element of an array. Of course, with the condition that both sides are the same data type. So once we print that, we will see the 0th element, which is the first element of the array, being executed, being printed on the screen. So, cannot understand this terminal here works. Yeah. Cannot read that. Isn't this the same file? Oh, yeah, this is the number. Yeah. I'm a little bit tired today, sorry, so I am not quick with my senses, but yeah, this terminal right here of Emacs has some strange habit of uh, of you know printing command, last command, and also the path we're working on currently, and all of this prompt to the screen before executing the command. So we see all of this bullshit before actually the program runs, which would print out 1, which is the first element of this array. Now, going on with strings now. In order to define strings, we need the word array, because a string is an array of characters, basically. You see, we have seen the data type char, which is short for character, and we can define this by this line over here, and you see that it is equal to 1 character and 1 character only from ASCII. By the way, we need to specify that the character works for ASCII and is now a little bit obsolete. All of the things we talk about texts and strings here are valid for ASCII strings, which is the English alphabet, and plus some fundamental punctuation and of course numbers and some escape and terminal sequences, but not the whole Turkish alphabet or some other international characters. So keep in mind that, and mostly if you're not working for the front end of a multinational application, you're not going to be needing these international character supports. But if you do need them, there are libraries to get around with that. But as I said, keep in mind that the standard character stuff we are going to be talking about here today are valid for the ASCII characters, which are represented by the character, which are represented by the char data type here, and the strings are not an official name in C, unlike many other languages, but they are defined as arrays of characters, which, as we've said, are ASCII characters, are ASCII literals, and you can define them. You must use this syntax, by the way, character array, just like the syntax of the previous array we defined here, just like this one. Of course, we can also define and later assign some variable to it. It's totally fine, but you have to use this syntax, this square bracket square parentheses after the name of the variable to tell the program that this is a string. Literally, this is a array of characters. And by the way, for the program, for the C, there's no difference in between this thing and this thing over here. They're both the same. They're both some sequence of values in RAM that are accessible through indexing of arrays. The difference is that there's no difference for C. The difference arises on how we interpret these kind of things, which is valid for all areas of computers. But for C, keep in mind that these are all the same. So whatever you can do to this, you can do to that, because they're the same. They're the same for us as well. We just want the functions to do different stuff with these. We just want functions to see this, recognize this as an array of characters, as a string, in order to sometimes print it on the screen. So this is, keep in mind that, and this becoming the same with a normal array also implies that we can define a string literal like so as well. I will not print the type the whole hello world here, but just to show you that this one also works, we're going to use a s specifier in the printf to format the writing into a string, and we're going to specify the name of the array. And by the way, unlike many other languages, again, as well, this is not the name for the array, actually. It's a pointer to the first element of the array, but what a pointer is and other these types of concepts, we're not going to go into that here, but just know that we're not passing the array to the printf, unlike the fact that, like, for example, here, we're passing a literal integer to the printf. we are passing that data type, but we are not passing array into printf now. We're just passing a pointer. What is a pointer? We're going to see in the later lectures. Oh, I'm getting a segmentation fault here. What's the problem? In this case, I'm going to be searching online because I did not study for my C, and this is a chance for you to see how programmers solve problems, okay? Now, this tells us to do that, so if we just omit this one, this works. But what doesn't work, as we can see from the documentation, is this one. Why? Let's test that. Whether it is the definition that makes the core dump or passing that variable to the printf that makes the core dump. So let's test that. So it works. The definition is not a problem with that. So let's pass this time to the program, and it works. And for some reason it did not here. Maybe I forgot to save that. But yeah, it should be working. The problem was probably we did not put this end of the string null in some other way of telling it, character at the end of our string, which is essential for C strings because C, as I said, treats strings as an array of characters and nothing more. Nothing more. So it does not have a specific kind of structure in itself in the program that says, this string is of that length that is encoded in this encoding. No, it does not. It literally does not have any kind of structure that tells a string that tells information about a string, like, it is not something like this. It is just an array. So in order to define the borders of a string, C uses this convention that it puts this null character at the end of each string to be able to know later with the functions that are dealing with strings that this is the end of the string and this is the last character to be printed, to be processed by the string processing functions. And why didn't we write that here? Because this notation, this double quote notation, handles this for us when writing this whole hello world and exclamation point to the RAM. It puts a little null sign at the end, a little null character at the end. So this occupies actually one more characters worth of place in RAM than we write it here. But this is literally the same with what we write it in here as. And you might also notice the difference between double quotes and the single quotes as well. Double quotes would indicate for C compiler that this is a string, and I mean an array of characters, and a single quote, on the other hand, would mean a character, a char. For example, this isn't a char for the C program because it's outside of the ASCII, it's outside of the English alphabet, and it's definitely not within the scope of the encoding that the char is able to meet. Okay, this is not a character, but this is. And we denote these with the double quotes and single quotes. So keep in mind that double quotes and single quotes do matter. And actually, if we were to test this out, we would get the error of invalid initializer. You cannot initialize it that. Actually, it's a warning because it would cast the data type of this wide character to the size of the char only, and there would be some bit operations, bit manipulations going on in the memory, and the first bit set of the whole integer, this would be represented in the memory with an integer, would be taken to the inside of the variable and not the others, and which would result in unexpected behavior, so don't do that. And we have the fact that we represent characters with solidly with numbers and with no abstraction almost in between, provides us with some cool little features in C, and we're gonna actually do that, showcase that with a function that would return the uppercase version of of a character A, let's say, for example, and its job is to basically uppercase whatever the character we're giving it to him. It will not, check for check to see if this actually is a character, if it is in the range of the characters, char data type. It will just, capitalize it as if it was a lowercase letter. So this means that the capitalization will also work for the capital letters, changing them into something else. The reason of which you'll see in a minute. But it's just a cool little showcase of a cool little feature we have in C. Not a feature really, but more like a showcase of what C does, basically. So you see, A has a specific number away from the little a in the ASCII table. Do we have a better one here? Like so. Yeah, we have a better one. The capital A, you see, is 41, and the lowercase a is 61. The capital B is 42. The lowercase b is 62. So they all have obviously the same number, the same difference in between them with their upper cases and lower cases. So by just subtracting, subtracting the amount of the difference between the capital A and not the capital A, but the lowercase a, and the capital A between from the input variable, we can get the uppercase version of that variable, and we'll showcase. You'll see when we apply this function and we run this function. So character is equal to, say, B, and we're gonna print that out using the formatters of the printf, like so. And you can see as well, did I write it down correctly? You can see as well that we have first defined the function outside of the main, before main, and we've wrote its code after the main. This is one thing you can utilize in C to not, confuse your readers with a lot of definitions, a lot of code before main, not to put the main at the end of the file so that they're struggling to find it, because main is the main function, and obviously it has to be read first when reading the source code. It increases your readability to define your functions before main and write their code after the main, which is actually the main philosophy behind dividing projects into different files. The same logic would apply there. You would, define your files, your functions in different files named, for example, we use stdio.h here. H is short for header file. Header file would only contain these definitions, not the code blocks, but only the names and the return values and the arguments of the functions and other structures and other kinds of stuff like that. It would only contain these and not the codes of these functions. But once you include that and the compiler compiles all of this stuff for you, the main function would know the existence of the function upper. For example, if it was coming from the stdio.h, and it would pass the arguments to that function wherever you used it. And in the runtime, when the time comes for the upper function to run, the C program would find the upper function's code block in some file named stdio.c, which has to be in some relevant directory of the compiler search path, and would just run the code block there. And you wouldn't need to write them all in a single file, thus making the file bulky and unreadable, okay? The header files are cool things, and this syntax is also possible as well for one-line functions at least. Actually, you can put lines of code like so, separating them by semicolons, because semicolons actually refer to the end of the code line, but it's pretty unreadable, so don't do that. Readability of your code and the documentation are really important things, and you can see our B is capitalized. Let's try it out with A. You can see also this is capitalized. You can try with the capital A, and you would get exclamation point. This totally random, not random really, but it showcases the fact that the char data type is solely this table right over here and nothing more. Let's move on with another showcase of this. And we're not going to be needing any functions here. We're only going to be writing some for loops, like so. And you can see for character data type, I am not forced to use the character because, as I said in the previous lecture, as we've said, they're all numbers that has different number of bits allocated for them in the memory. They're all numbers. In C particularly, the compiler, the language treats them all as numbers and no character is designated. The char's name is there only for the convenience, and the C program is not aware anything about the variable being about a character, a text, a string. It's not aware of that, so you can use int, you can use double, you can use float, and if you use the correct formatting in printf or some other kind of way of interacting with the outside environment, the odds work for you. Okay, so we're gonna be doing such a thing. Yeah, this is the thing that we're needing. So I think you can already guess what's gonna happen. And this is what we got. We just printed the whole alphabet. And you can also do this the capital letters as well. It would just fine. You see, we printed them sequence, and you can also do this as well. Not this, and that, because the capital letters came first, remember. And you would get all of the symbols in between the capital and the lowercase letters in here as well. And we can compare that, the brackets, the slash, the this, the dash, not the dash, I'm forgetting many words here. It's written here under course, and they're all here. Okay. So another thing that is valid for arrays, which is also valid for strings, is this. You can define a string here. I hope the word is not designated, and you can say hello world. and you can change any of the letters, characters. I don't want to say letter because it's not correct. You can change any of the characters inside of this stringlet through this syntax, through this indexing method, and you would get the desired good result. It would work just fine. So I just save this. I save this file. I don't understand Emacs sometimes. Yes, I don't want to do that. That does not work once again. Why can't I save my get rid of no no. All right, I'm switching to Win. Just go off screen a little bit. Okay. Sorry for the inconvenience, but you know, I have to configure my Emacs and learn to use it, but I'm very much in the lazy side of things, so this now what the actual okay this here and there's no lecture, which is really annoying.
Abi senin ekran dondu da.
Durdurdum.
Ha tamam.
Sorry for the inconvenience. I had a little bit of a problem, Peter. Now everything is fine. Hopefully, I lost the lecture content. To be honest, it's fine. I'm gonna pull that out nicely and calmly. Just to remind myself what we were going to see in this lecture. I'm just gonna do this. Now it's strings, get line station, the char, the get char, yeah, get char. C is going to be like so. What example was that? The terminal nodes, file descriptors, the terminal and shell terminology, the string and C type, the IO functions. Then we had quest specific applications, specific applications and APIs and APIs. And we had nothing more, I guess, to cover today. Maybe we had a little bit more of exercises, but I guess we're not going to be able to execute them, which is really sad. I'm thinking of ways to get around this. But no, actually, we don't need more examples. These are just fine because the last ones are just going to be showcases, not showcases, but explaining how a function works really, because they're really just two basic functions that we're going to cover at the end of the lecture here. So let's implement this getLine function, shall we? Okay. So getLine actually is an implemented function, of course, in the stdio.h. I guess so. It has to be in stdio.h. Let's see here. And it's in the stdio, so we cannot define a function called getLine, but we can define a function called getLine underscore. So we're gonna do that. We're gonna do this, and I'm not gonna do anything more, I guess. All right, am I right? Yeah. We're just gonna define the function like so. Okay, so we have some kind of restrictions here. We have also the specification of in the original get line, really, we have some more arguments. We have the file from which the get line will get the characters, and we have some restriction as to how many characters it can get before the buffer flows up. But yeah, actually, we need to get this one as well. But the about the file, we're not going to concern ourselves because we don't know about these just yet. We're just gonna write a cool little function here, and we're gonna open our function. So the get line has to, from the standard input, get characters one by one and copy them into the array string until either a new line character, which is this, not this is encountered, or the maximum length is exceeded. So we're going to do that by first defining a for loop here. For counted loops, this is the best way to go. And until it is lower than the length, we said lower, not lower and equal, because we start the I from 0. So when I is at the length, it's going to be that the length amount of characters would be filled within the string array. And also we need to specify the condition that the return of the get char for assigning this variable here is not EOF, or it is not equal to a new line. Okay, you see what we're doing here, and we're just gonna we're not gonna open our brackets here. This is a thing as well. If you're just gonna be writing one line to a loop, you don't need to put these parentheses after and before the for loop, but after the for loop. And we're just gonna chill out and say this is our thing. You don't forget the semicolon, by the way. And this is a 0. This is the function. So you might be wondering what's that. This is arkadaşlar an assignment, as you can see, and in C assignments have return values. So when this assignment is complete, it's going to return the value that is assigned to that variable, that C right over here, and put it right into here. You can think this as an operation. You can think of it as, something like this. You can think of it as an operation, but instead of a plus, we have an equal sign. And the end of the result of the operation, which is in our case, the assignment operation, is going to be put inside of this parentheses, and we are going to be able to use it in our code. So do keep this in mind. This is a pretty useful structure. This is a pretty useful feature, really. And once this assignment is complete, we're going to check for whether the C is equal to the new line as well, to see if it is it's a new line. We're just gonna completely function because it's get line, it's in its name. It's gonna get the line and stop, so we're looking for a new line symbol. And you may notice as well here that the assigned value just before this one here, the assigned C, will hold for here and here. So this is a valid assignment that is valid for all of the scopes that C is defined in. And once it reaches an end of the line symbol, it's going to stop counting more. And what does E of mean? It's short for end of line, end of file, not end of line. In Unix-like operating systems, which include Linux and Mac OS, the communication with the outside channels in a program with the operating system is done through files. You want to, display something in the monitor, you write to a file associated with the driver of that monitor. You want to, use the microphone, you get the microphone input from a file associated with this microphone's driver. Everything is done through files. So they decided that, well, let's use the files for all of the interfaces, then let's define a general library for them, and generalized things would also include a sign for when this file and of course it's not always a file. Like, for example, we said it can be an input from a microphone and it will have an end, or a file you're reading from the disk will have an end as well. So you would need to have a way of telling whether the stream of data, the stream is a technical term here used by C, by the way, is ended or not. You will need to have a way of telling it, and this is the thing. The EOF symbol is a defined macro, is a defined constant in the stdio library that specifies the end of the file is reached, and when the character is equal to end of the file, it means that the input stream has ended. Now, in such a program as the one we are writing right now, this will probably not happen because we're writing from the terminal, right? We can write for how many years you want, not that we're able to. But we still use it for convenience features, for conveniency, because for more complex problems, programs, the terminal input may raise some errors in the process, and the E of debugging would be useful in handling such a situation. But for now, we're just gonna let it go there and enjoy our day. And you would also notice the modification we're doing to string named string here works. This is an argument to the getLine function, and we're changing the content of the getLine function inside of the function, and we're expecting the original string, which we're going to pass to this function in a minute, just in the main function of the program, to be changed by the modifications inside of the getLine function. How would that be possible, you may ask? Because, if you were to change the argument length, for example, if we did that here, let's say length be 10, after inside the function, if we did that, this, yeah, we can change the variables, value, of course, but it would not be reflected in the actual value that is passed to the get line here, which let's say is 12. And actually, let's define it this way. Do that. If you were to change the content of length, the value of length inside of the function, it would not affect the actual length variable inside the main function. But in the case of the string, which let's define right over here, it would affect that. It would affect the content of this string variable here. The reason is linked to the pointers, which we're not going to get into again, as I'm saying here in this video, in this lecture. But the reason is linked to the pointers, and this actually does modify the string right over here. It may sound illogical to you, but once you understand pointers, it would make complete sense, and it's a great, beautiful thing, okay? And you can also see that we're not returning any strings from this function. You may be accustomed from other languages to return strings or return arrays. This is not the case for the C because as we've said, there's no data type as arrays. There's pointers, there's, integers, chars, which are smaller integers, but let's pass on that. But we have no data type called arrays, they're pointers. So we cannot return the array, really. We have to, if you want to return some kind of array, we cannot, but we can modify some given array to pass out our function's results to the actual calling function. Okay, this is the convention for C. But you can also say you can see that we return some value here, and the reason for that is the C functions and generally in the functions in programming in general, they return some kind of value in order to inform the calling process of what happens inside of the function. So one can say whether an error happened, whether some other case has happened. You can tell and act accordingly. For example, if the if the end of the file is reached, we may assert some kind of error here by returning 2 or by returning 1. And so this is also possible as well. We're seeing a lot of shortcuts. I'm forgetting a lot of words today. Let's change that to this. And this is only defined here, so we're gonna have to do that. Notice if we were to define the int I inside of the for loop, it would not be visible outside of the for loop. Let's if you were to have such a situation here where no character could be read for some reason, we would return 1 to notify the caller function that some kind of error had occurred, and it would tell the user that some kind of error occurred and no characters could be read. Of course, this has to have this and it would also return 1 because there's some kind of error, and we need to, inform the operating system about it because the programs are usually pipelined in the operating system. You don't see that in your graphical operating systems, graphical environments such as Windows and Mac OS. You don't see them, but in the background, they're all called from a command line and they're all pipelined to each other. For example, I tell my computer to execute some program one and take its output and give it to another program, and then take its output and give it to another program so that they work in tandem. Every program does one thing and eventually achieve what the computer desires at the moment. And once they're pipelined, they have to know what went on when some one of them was executed so that they can act accordingly. So we use the return values for that as well. And if the nothing happened, actually we don't need to put else for that. We just print f the string typed maybe this thing and then new line, because we did not include the new line in our string, you notice here. And we just pass on the string. And one thing we forgot to do is the not the string, the null terminator, call it. We have to do it like for a string. Otherwise, the C would not know where the string would end, and when trying to print it in the printf, it would continue printing everything it finds in memory. I'm not saying the program, the scope of the program in the whole RAM of your computer. It would try to find a null terminated character, and until it finds it, it would print whatever the hell goes on, passes its way. Okay, so we have to terminate the string. So let's run this gcc lecture.c lecture and then run the program. Okay, cannot type today. See, okay, you can see, and also you can see that as well. We tested all of these things out and it worked out really, really, really great. Another thing I want to showcase here, let's stick these all into comments and let's do something like this. While C equals get char. By the way, these function, the get char function, I think you know what it does right now. It just takes the first character it finds on the screen and returns it. We'll get into more detail about that. If get char C is not equal to this thing, the new line, just char it, print it basically. Let's run this function and see if you notice something peculiar. Okay. Why am I so not careful today? We run the function. No. Before that, let's just see what it has to do. It has to take our input until the end of the line is reached, and then it has to print it. Okay, it's a basic function. It's a basic program. Let's run it. I write some letters. Actually, that's not complicated that much. Just write hello world and then type print. Press enter. And you see it echoes. It rewrites what I wrote there, but there's some kind of a problem, you see. According to the program, every time it takes a character from the terminal, if it's not equal to the end of the line, it has to print that to screen. But it does not do that. No. It first waits me to write the whole line and press enter, and then it writes it. Of course, it echoes what I wrote here while I'm typing these in the terminal. They're all echoed, as in the case of right now. I'm pressing O and it echoes O on the screen, but this is not related to our program. This is the echoing feature of the terminal, and you can see that this kind of typing right now is not from our program, because once we press enter, it would retype all of these to the screen, reprint all of these to the screen, and our program in the source code does not print things 2 times to the screen. So what happens here? What happens is that our terminal is in echo mode, which is the default mode for most of our terminals, which is the line mode, which is it waits until enter is pressed. The terminal, the program that is taking this input and passing it onto our program here, the workings of this is like so. We're gonna learn more about that in a minute. The terminal, this whole application called Alacrity here, when I run this, when I run the program, when I run our program here, the alacrity, this whole black screen, gray screen you see here, is the one that communicates with my keyboard to take these inputs, to take these letters from the keyboard and echoes them to screen. It is the alacrity, and it's alacrity's job to pass these letters to my program called lecture in order for it to do its thing, because it requests through get char through this function here, which is implemented in the standard library, the systems programming. It requests from the alacrity through this function to pass it whatever is written through the keyboard by the user. So it is alacrity's job to pass them to the program, but alacrity is in the line mode, which means it would not send its input until the enter is pressed. It's in the line mode. It sends the data line by line, It sends them. Once the enter is pressed, it sends them to the program. So it does not get actually all of them in one move. So all of them one by one. It gets them all in one move. So you may ask them, this get char works only for one character only. How can it loop over all of these characters once it gets the stream and prints them all out? Well, get char is defined to, get the next character from a stream of data, which is in this case, this thing over here. It gets the next character because these are all buffered in a file descriptor, in a file called standard input. Standard input is what standard input is, we're going to mention in a minute, but these are all stored in a buffer, in a variable called, you may say, standard input for the program called lecture. It is stored inside of this buffer, standard input. And when the get char tries to read from it, because it is programmed to read from the standard input, it is not programmed to read from the keyboard. It is programmed to be reading from the standard input. If with some way, and there are ways to do that, we set the standard input for this program to be, some kind of YouTube video, it would try to print the link of this YouTube video, okay? It would try to get the characters of the YouTube link, and it would not be concerned with the console, the keyboard, okay? And it's programmed to get the characters from the standard input, and the standard input is buffered with all of this at once by alacrity, because as we've said, alacrity sends in the data only when the enter is pressed, and I press the enter after hitting the key here, K here, and alacrity sets the buffer to hold this whole string right over here. So, and then came the job of the get char. It started out the first character, it got it. It was not an end of the line, so it continued, and while it's continuing, it also passes this character to the put char, and it puts it on the screen. So it gets that, and once it reaches the end of the line, it terminates its operation. This is how this works, how the output of this program is like so, and not like this one, okay? The output is this, not this. The characters are not doubled. Do you understand what I'm saying here? This is because a little bit complex concept. You understand? Do you get what we mean?
Hata.
Great. By your brain thinking about it in the background, the future, you'll get to know more about that. This is the wider. Let's talk more about these file descriptors. File descriptors, as you know, files are files stored in disk, and programs may need to access them to do some kind of, data exchange, to interact with the outside world. And as we've specified previously in this lecture, that in Unix-like operating systems and in Windows as well, to some extent, everything is a file. So the programs interact with the outside world through just read and write functions that are defined for files. These are the basic syntax of interacting with the outside world for a C program. And whenever a C program opens a file to read, to write, to do something with it, we call the operation open to inform the operating system of our trial of accessing the file. And once we manage to access the file, the operating system will assign to our process a file descriptor, which would include all of the information needed to do some things with this specific kind of file. And once a program starts, operating system by default from the very beginning assigns three distinct file descriptors, which are called 0, 1, and 2, which are standard inputs, or sorry. And by the way, files, as you know, can be either output or inputs. You know, we can write to a file or we can read from a file. Let me just check the file descriptor for each one of them. So stdin, or in its other name, standard input is 0, so standard input. So this one is standard output, and this is standard error. These are assigned to every program, whether it's C or not, whether it's in C or not, are assigned to each program at the beginning of its execution by the operating system. This is done to ensure that the program, from its very beginning, has some way of interacting with the outside world. And by convention, the standard input is usually this terminal screen. And the standard output is usually the terminal screen. And standard error is usually the terminal screen. So back in the day, people had no graphical environments and they had big black screens that provided a way to interact with the computer that had some operating system on it, usually Unix in the early days. And people, just like in this terminal, would write commands into it and press enter, and the command would execute and do something for them. They may edit some file, they may download it from the internet, they may read some things, they may compute something automatically, and they could program things. They could write programs through programming languages. And each of the program that running inside of this console, is machine right over here, had to have some way of interacting with the outside environment, and they had the keyboard and the screen for that. But when the Unix came out, before the Unix came out, every individual program had to write its own kind of code to interact with the screen and the keyboard, and it was a lot of work for programmers. For each program you would write, you had to rewrite the same code of trying to print the screen and trying to get the input from the keyboard. Every time you write a program, you had to implement that. But Unix changed that by introducing files. They introduced the communication with the terminal through file descriptors. They created files and said, just write on the file and we'll display the image and we'll display the characters for you on the screen, on this console. And you don't need to worry about how the screen works or how the keyboard works. And we are just going to assign you some file descriptors to do that, because the programmer needs to know to write to which file in order to, the programmer needs to know which file is to be written. Okay, it needs to know that standard input is 0, so it would tell the function write, which is concerned with writing to files, to write his specific text to the 0th file in the file descriptor tables of his program. Sorry, 1 standard output. He would need to specify this. So file descriptors are basically the program's way of identifying between different files open for it, and in order to make things easier, provide a default way of interacting with the environment for the programmer, operating systems assign these 3 standard, and by standard we mean the absolute default thing we've been talking about for the last 10 minutes. Operating systems assign each program these file descriptors for them to interact with their environment by default. Of course, programs through execution can increase or decrease their ways of interacting with the environment. For example, they can access a microphone through their execution, or they can access the monitor through some kind of graphical environment. And they may close the microphone as if we're closing the microphone in the Zoom right now. But these standard input, output, and errors stay all the same. And even for your graphical applications, you're running Windows or macOS probably, and you are using graphical applications in there. But don't forget, even if you don't see them, all of them are happening in the background through command lines. Windows and macOS just doesn't show them, but they're all happening in the command lines. The programs call themselves the your app launcher, which is app searcher in the desktop. For example, you click an icon and it launches a program. It works through calling the program from a command line in the background that you don't see. And also the programs called from there use standard input, output, and error to, at least output and error to, log what's happening, or, just to save the more advanced users what's going on behind the scenes of that program. They really do. They really use that, and it's pretty necessary because uh, for debugging jobs, and they're not for advanced. They're for sometimes advanced users, but they're required for the operation of your computer. Okay, because you don't use it, maybe you don't use the standard output, but another program uses the standard output to communicate with another program, because they don't want to create a whole image processing library to take a screenshot of your desktop and then try to figure out what they are doing. They just communicate through text channels, which are standard output and input. Sorry, I have to give a pause here. I'll be back in a minute.
Okay.
Sorry about that. I'm back. Can you hear me?
Yeah.
Okay, we were talking about the file descriptors, and now we can get to the terminal and shell, which are actually we've talked about them. What terminal is, and how it works. Terminal is basically this thing. It's not this thing, okay? It's this thing. It's this machine that was used way back ago, and but after the home computers were introduced, these were not used in homes, you know. Back when these were used, computers were not a home thing. They were not for home use, okay? They were for workplaces. They were for big government agencies for the most part. But when the computers were introduced to the homes, the houses of the people who the people had to have some way of interacting with the computer, so they had to move this to the home. But these were too bulky because what you see here is not a computer. This is a terminal, and terminal has only the function of displaying things. It does not have the function of computing things. It was just connected to physically connected to some mainframe, some central computer in the building, and all of the people who were using the computer we're using the same computer through different users and sometimes the same users with through different monitors and keyboards. You may think of it as so. And these were bulky and heavy devices, and we wanted to integrate the computing side and the keyboard and the monitor side to the same device. So we came up with the first home computers. Okay. And these things, they were less bulky and integrated everything into each other, but they had to have some kind of terminalizing things again. They had to use a terminal, but they do not have the device. So they created programs that mimicked the operation of terminals, which are terminal emulators. The word emulate would sound familiar to you. It is some program that mimics the functions of some hardware or some other software. Maybe sometimes I think it can be used. I don't know. Maybe it is not a correct term, but these programs, like for example, in my case, Alacrity. I use Alacrity. You see, are our programs are terminal emulators that emulate these terminals we've shown you here. So actually calling these terminals are not correct. These are terminal emulators, okay? Their sole function is to get the input from you and line by line pass them to the shell, to a program called shell, which is what actually, you know, interprets, makes sense of your commands. For example, it sees this CD and then sees these words, and then once you hit enter, it says, well, I have to I have to change my directory into pointer arrays, and it does that. The terminal emulator, the terminal does not do that. What does this is the shell. The terminal emulator is just a way for the shell to interact with the outside world. Again, we're repeating this, but terminal is just there to, you know, get your input, and while writing it, it echoes on the screen because you can see what you're writing, and it sends this input to the shell, and whatever the shell outputs, it puts that onto the screen. Okay, for example, the shell in my case it is ZSH, but the most common one in Linux is bash, but I use ZSH. In this case, ZSH echoed outputted this, and the terminal put that on my screen. And then ZSH echoed outputted this. This is not from the terminal as well, and this is not from the terminal as well. I, colorize these by configuring my ZSH, not my terminal. My terminal configuration only includes the background color, okay? It does, and the font, nothing more, okay? So terminal's job is to get the output, get the input from the user to the shell, and then get the output from the shell to the user. And shells fire descriptors, standard input and standard output, are assigned to the terminal, and also the standard error as well. And you may ask the difference between standard error and standard output. It's basically the same. They're both outputs, but it is a convention to output your errors into standard errors. So when a user wants to distinguish in between them, for example, he wants to know the errors only so he can debug them. He redirects the standard error into some file in his computer, some real file, really, one you can read, some text file, some TXT file, so that he can be able to distinguish in between. This may sound like some useless stuff for you and something that is only for advanced user, but trust me, it is widely used in the programming world. Without any of this, without terminals are not hypothetical for fun hobbyistic things. They are the most efficient way of interacting with your computer, and without these, the programming world would not exist. Just remind yourselves of that. Nothing here is for hobby only. They're for hobbies as well, but not only for that. So the name standard is also used in standard IO. Standard output is the long name of this library. So it is dealing with the standard input and the standard output, and by standard output it encompasses the standard error as well. And yeah, the terminal sends the information to the shell, which then interprets it and outputs whatever it wants. And a shell is nothing more than a programming language as well. Okay, it's actually a Turing-complete programming language that can write programs in, and you may not see them often, but if you program some big project in the future, the big projects utilize this a lot. They write scripts that are run by the computer. Shells are programming languages, but they're designed to more efficiently interact with the operating system rather than prioritizing performance. Okay, they're designed to be more OS friendly. So the parts of the programs where efficient and easy and fast OS interaction is required and no performance is much needed, people use shell scripts. They integrate them into their source code, mostly in the installer scripts. For example, if you were to, just do some stuff with your Windows computer, you would see some files called, for example, script.bat. The files that end with bat include a batch script, which is the shell script used in Windows, okay? The programs do utilize this, and one example of a shell script is my configuration of CSH. You can see here, I can define functions, I can define variables, I can use them, I can use commands. Do we have a mathematical operation? We have logical operations here, and you have to be familiar with that from C. We have string literals and other kinds of literals. We have comments. All of the things that are needed to comprise a programming language exists here. But as I've said, they're used in contexts, sometimes to configure things, sometimes to install programs, and sometimes just for fun or some easiness, hack around with your system. And you may want to search about this as well. Ortam değişkenleri in Windows. You may want to search about this as well. This is a pretty important concept in the higher levels of the operating system's workings. And if you are even a little bit of an advanced user, you would have definitely encountered this ortam değişkenleri. And shell scripts are usually the way to go, even if you don't see them, to manipulate the environment of a operating system or a program. Okay, these are some important yet not whose importance are not widely known concepts. So this is we have file descriptors, terminals, chans, and IO functions. Let's just go over them real quick. Okay. We have a and by the way, an interpreter works by interpreting line by line. For example, if the C was some interpreted language and languages are divided into interpreted and compiled, compiled means it is compiled down to the machine code and to the zeros and ones, and the exe file is executed on the CPU. And an interpreted language means it's never been compiled to the zeros and ones, but instead, when you run the program, a specific program called interpreter, line by line goes over it and does whatever the command says. An example to an interpreted language is shell scripts. So shell is a programming language, and it can interpret, because it can interpret things line by line, actually it does the same thing while reading from this terminal input and while reading from this ZSH configuration. It just goes over them and does whatever each line says without regarding to them as separate things. They're the same for ZSH, okay? And another example for interpreted language is Python. Another one is JavaScript. Another one is Ruby, I guess. And for compiled languages, we may exemplify C, C++, C Sharp, Fortran, Rust in the recent years, and many other languages pretty much, and especially the old ones. But the most popular example for the interpreted languages is Python, and the most popular for compiled is probably C or C++. Yeah. So let's have a look at the input-output functions. See, let's see. Do we have good documentation about C libraries? We do. We have the Linux manual pages, and we see the list of the functions that these libraries possess. We're going to only focus on a few of these things. We will see them in the future, hopefully. Fclose, fdopen, these are, linked with file operations. But as we've said, standard input and output, printing screen and getting input from the screen is also writing to a file and reading data from the file. So actually our functions such as printf or getchar are just, functions that call these file writing functions, but pass the file argument for us as the standard input or output or error, whatever you want to do. Okay, so we have getC, which is a more low-level version of getchar. In getC, you have to specify which file we want to write to, but they're both the same. You just you just get the next character from that data stream, okay? And gets a line from a stream, the get line function, you remember this one? We implemented gets is the same as that. And when you want to use these functions, you have to go to their manual, okay? It can be this manual, or you can write it on the internet. And by doing this over and over again, you will be able to differentiate between good and bad documentation, good and bad websites, and you would also be able to know to better research. This is one of the reasons why I don't specifically explain and give many examples about how to use the programming structures in this lecture series, because you have to learn them yourself. This is the best way to learn. Okay, we just show you the way and give a context, and you pave your way through it, because the programmer needs to know to research and solve problems. And these skills are only acquired when you're trying to find your way on your own. Okay, this is the thing. You have to keep that in mind. And you have to teach yourself self-learning. This is one of the most important skills. Okay. any of the fields in general. Okay, so you write the function's name into the internet, and as I said, from by the time passes, you would be able to differentiate between good sources and bad resources by reading a few lines from the beginning. So you can and you will be able to read faster, not because of the language, but you would be able to say by reading the first couple of words here, this paragraph is not of my concern. I don't have to read it. So let's pass that. I need the you would be able to realize what information you really need. In this case, what getchar does. You just have to know its return value and its arguments. So you would just pass on to that section immediately and read it fast. You don't have to read every word. This reflex would develop over time, and the only way to get this is to self-learn, self-teach you. Okay, this is the only way to learn programming, and programming is not learned from listening from somebody else. Okay, and this skill will not hold you for programming only. This skill is essential for any kind of thing you do in your life, and it would be a great addition to your mind. Okay, let's see, get char returns an int and it takes no arguments. Return value, input from the standard input is read as an unsigned char, and then it's typecast and returned as an integer value. EOF is returned in two cases. So it returns whatever it reads as an unsigned char. Okay, data types, pay attention to data types. And end of the file is returned when the file end is reached or when there's an error during the execution. So you have to, as a programmer, be aware of the functions you use in your programs, what their return values are, and calculate all of the possible ways the program could go and write specific scenarios for each of them. So you can have a return value of the actual char you want to read. So you have to write a way to print it. But you can also have EOF. You have to take measurements to deal with EOF. When EOF is returned, what you want to do with your program. You want to just exit, or you want to pass on it and try again. What do you want to do? Okay? You have to be aware of the functions or the libraries you're using. So you have to read documentation constantly. Gets is the same, just takes a line. And we have printf as well, which we talked about a lot. Putc is the output version of getc, and putchar as well, and puts, pardon, puts, yeah. And do we have something significant here? No, we only have scanf to show a little bit more about the scanf. Actually, let's show it from W3 tutorial sprint. This is not a bad website. I still use it from time to time. This is not an expert site, good site, but it's a fair one, especially for the beginning, or if you want to have some quick surface level information about something, about some programming language. This site is fine. This site is Linux manual pages online. Actually, this would not be a good resource if you're outside of the Linux, if you're not programming for Linux, but hopefully we have the NSI standards, which define how a C program, what is C, they define from time to time, they release standardizations on what C is, what syntax does what, and every compiler needs to obey that in order to be valid and be used by programmers. So they define the standard libraries of the C as well. So across all operating systems, the functions, arguments, these standard library functions, arguments, and return values, and their specific details, except for the non-mattering implementations, should be the same. So your Linux manual page should give the correct idea of how this function would work in Windows as well. But pay attention to that while developing a platform-specific, OS-specific, hardware-specific application in the future. But these kind of things are designed to be portable from everywhere to everywhere, because you don't want to write separate source code for each operating system, which some of the libraries have to do. these things are standard. But when it is compiled to this exe, it is not portable. It is specific to OS because when compiled, when compiled for Windows, it takes the functions from the Windows's version of the C standard library, and when compiled for Linux, it takes the functions from the Linux's version of standard library. And they're different because the operating system is different. Therefore, the way to interact it, the way Linux kernel and Windows kernel provide to outside the way of interaction are different. They use different protocols, they use different standards, they use different timings, there are technical details to that. Their functions differ. So they're even though the arguments and the return values of these functions are not different, their implementations, their insides are different. The inside of the function for the Linux would not work in Windows and vice versa. So because of that, you have exe files in Windows that do not work in Mac OS. You have to download separate ones with them. Okay, that's why in the websites of programs, they say download for Mac, download for Windows, etc. Okay, let's continue with scanf. Again, we'll just go through it on the screen. It is actually the printf, but input version. You specify through similar specifications, through different similar formats, what kind of um input, what kind of data type you want the user to input. You specify them in this format, and then you give your variables name, in the following order, of course, but you put an ampersand before the name. The whys of this you will be able to again know when we go over pointers. Okay, and then just like printf, you can put many arguments here. There's no limit, and each one of them will be read according to the format. So for example, if you were to specify D for this and you would try to do some different kind of thing and data type, it will not work. Okay, and you don't have to use multiple variables as well, and I think it is not recommended to use many variables because users may not be able to understand how to differentiate between them. Like for example, let's run this example. Run that. Don't they have like a rerunning option? Sorry. Not really. How do we run that? Okay. We have to use an online C editor. So I don't want to. Okay. Let's use this one. Oh, this is the one. Okay. This is the one we've used previously. Okay, let's run this. So type a number and a character and press enter. Do this. So it is able to differentiate in between them. But to do this, still able to differentiate in between them. Let's do this. Still able to differentiate in between them. So it is. Let's try that. Let's save to my thought or something. I didn't know. Okay, it did not work. Sorry. See, this is the thing. This is the problem with taking multiple outputs, inputs. You have to be aware of how it works. Okay, before using it, you can just intuitively say. You can't just intuitively think this should work this way, so I have to do that. Okay, you have to read the documentation. And there was one thing I wanted to say about this as well, but I forgot it. What was it? I literally forgot it. So now we can implement the input function from Python. You're familiar with Python as well here. Let's do. We have the input string, and we have the output. Let's just, for the sake of the simplicity, we limit our input to integers, so we return the integer, but you can do with more time and more complexity, not much more. You can implement this for all types of variables, even for structs, if you format them correctly. Okay, we just print up the and with the space string, and we scanf this integer into ret value ret, and we return it. What does it say? Why is the call scanf is insecure, as it does not provide security checks introduced? Okay. No, we don't need to worry about that for now. It is for when you write when you really write C code, you have to be aware of some things that you don't need to be aware of in Python, because C is so flexible, it gives you many things to do, many space to explore, because you have such freedom, you have such danger of putting your code in insecurity, and we're not gonna get into those because that's a whole another topic, really big one. So let's just comment these, and let's just print your input is this, then a new line, and input with please input digits and integer, not a digit. So GCC lecture, let's see, lecture, and then lecture. The integer I input your input is that. So okay, I guess that's about it. I wanted to mention a little bit about string and C-type libraries, but I think with your ability, with being able to research on the internet, you would have no problem knowing about these. These are just functions who deal with strings. They have comparing two strings, copying one to another. Finding the length, concatenating. It's a term to merge two strings. Copying, but with a specific number of characters. The first occurrence of a character, finding it in a string. These kinds of utility functions that you can easily implement by yourself, and I suggest you do, because they're fun and they're good exercises, but you cannot do that for the most part, at least now, because you don't know about the pointers. And I wanted to also introduce you to C type H library. These are mostly macros, by the way. They're not functions, because calling a function requires a lot more power, a lot more CPU power to execute. So instead, these are just macros. You remember the defines the preprocessor macros, like these, that would be replaced whenever an instance of them seen in the code before beginning to compile, even parse, even lexing these, they would be replaced with whatever the value we give them. Well, they have also a better way of implementing these, like so. So if I were to write this down like so, preprocessor would change this to this. Okay. We can define a macro. We call this a macro. We can have it like a function. So these are just macros to whatever their functions have to be. They do not call functions in order to gain performance. Okay. The C-type library is also a cool library, which would be useful in your programming. Because if you're familiar with Python, you would expect all of these to come as you write the code, but they do not. They're in the standard library. Standard IO is not the standard library. It's a part of the standard library. It's the IO part of the standard library. They're in the standard library, which for all programming languages should be. And also, while running the Python, what Python first does is to include the, I guess, standard library of its own to be able to give you the access to functions such as input, the print, or the string class. Okay, Python has a class called string, or even the list, the tuple, the dict, these kinds of stuff. It has to include its standard library, I presume, or some other way of doing it. But this is totally normal. Do not be scared away by this. And writing one line of include C type .h is not that hard. Okay, so that's it for today's lecture. If you have any questions or something to say, we can hear it now. And if you don't, we will just end this one. Do you have?
No, I don't have any.
Okay, then we can end the session, I guess. Goodbye to you all.
Goodbye.